Study about trigonometric functions. Consider a unit circle with center at origin of the coordinate axis where the points A, B, C and D and the intersection point of circumference of circle and coordinate axis. So, the coordinates of points A, B, C and D will be 1, 0, 0, 1, -1, 0 and 0, -1. Let P, A, B be any point on the unit circle with center at the origin such that angle AOP equals x radian, that is, length of arc AP equals x. Now, draw a perpendicular PM from point P along the x-axis. We define cos x equals A and sin x equals B. Since OMP is a right triangle, we have OM square plus MP square equals OP square. We get this by Pythagoras theorem. Now replacing OM by A, MP by B and OP by 1, since OP equals 1, we get A square plus B square equals 1 square. On simplifying this, we get A square plus B square equals 1. Replacing A by cos x and B by sin x, we get A square plus B square equals 1 as cos square x plus sin square x equals 1. Since one complete revolution subtends an angle of 2 pi radian at the center of the circle, angle AOB equals pi by 2, angle AOC equals pi, and angle AOD equals minus pi by 2. All angles which are integral multiples of pi by 2 are called quadrantal angles. The coordinates of the points A, B, C and D are respectively 1, 0, 0, 1, -1, 0 and 0, -1. Therefore, for quadrantal angles, we have cos 0 degree equals 1, sin 0 degree equals 0, cos pi by 2 equals 0, sin pi by 2 equals 1, cos pi equals -1, sin pi equals 0, cos 3 pi by 2 equals 0, sin 3 pi by 2 equals -1, cos 2 pi equals 1, sin 2 pi equals 0. Now, if we take one complete revolution from the point P, we again come back to the same point P. Thus, we also observe that if x increases or decreases by any integral multiple of 2 pi, the values of sine and cosine functions do not change. Rotation in anti-clockwise direction. Rotation in clockwise direction. Thus, sine 2n pi plus x equals sin x, where n is an integer. Cos 2n pi plus x equals cos x, where n is an integer. Further, sin x equals 0 if x equals 0, x equals plus or minus pi, x equals plus or minus 2 pi, or so on. That is when x is an integral multiple of pi. And cos x equals 0 if x equals plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2, that is cos x vanishes when x is an odd multiple of pi by 2. Sin x equals 0 implies x equals n pi, where n is an integer. Cos x equals 0 implies x equals 2n plus 1 into pi by 2, where n is an integer. We now define other trigonometric functions in terms of sine and cosine functions. Cosec x equals 1 by sine x, where x is not equal to n pi and n is an integer. Sec x equals 1 by cos x, where x is not equal to 2n plus 1 pi by 2, where n is an integer. Tan x equals sin x by cos x, where x is not equal to 2n plus 1 pi by 2 and n is any integer. Cot x equals cos x by sin x, where x is not equal to n pi, where n is any integer. Let us study some standard identities. The first one is 1 plus tan square x equals sec square x. Let us see the proof. 1 plus tan square x, which is the left hand side. We know that tan x equals sin x by cos x. So we write it as 1 plus sin square x by cos square x. On simplifying, we get cos square x plus sin square x by cos square x. We know that cos square x plus sin square x equals 1. So this could be simplified to 1 by cos square x. We know that 1 by cos x equals sec x. So we get sec square x, which is equal to the right hand side, hence proved. The second identity is 1 plus cot square x equals cosec square x. Let us observe the proof. The left hand side is 1 plus cot square x. We know that cot x equals cos x by sin x. So the left hand side could be simplified to 1 plus cos square x by sin square x, which could be written as sin square x plus cos square x by sin square x. We know that sin square x plus cos square x equals 1. So it simplifies to 1 by sin square x. We know that 1 by sin x equals cosec x. So this simplifies to cosec square x, which is the right hand side, hence proved. Now let us see the values of sin x, cos x and tan x from 0 to 2 pi. We have the values for 0, pi by 6, pi by 4, pi by 3, pi by 2, pi, 3 pi by 2 and 2 pi.